Integers, part one, some basics. Let's go over some basic ideas and some easy trip-ups so that you won't be tripped up when it comes. Suppose you're presented with this statement, all integers are either positive or negative. What would your reaction be? Would you say, yeah, I say that's true? Or would you say, only on certain days, maybe only on days that end with Y? No, not Y. But anyway, look at the number line. Look at the number line, Mr. Deal. All the integers are either positive or negative. Not so fast, not so fast. This statement is almost true, but it's not exactly true. How can we make it true? By adding two little words. You ready? We'll put them right here. And the words are non-zero. All non-zero integers are either positive or negative. That is a true statement because 0 is neither positive nor negative. It's nothing. So all integers are either positive or negative as long as they are not 0. Okay? Now that can be sort of construed as something of a trick question, but it is a very practical trick question. So that's why it's good to reinforce this, to talk about it, to make sure that you understand. Technically speaking, this is true, that all non-zero integers are either positive or negative. Okay? How about this? Integers with opposite signs have the same absolute value. Well, I'm going to tell you the truth. When I first saw this question, I thought, yeah, that seems right to me. Sure, yeah. But it's a trick question a little bit. It's one of those where you can make the argument either way, but if you can make the argument that this is not the case reasonably, then you have to clarify it, okay? So let's clarify it. Integers with opposite signs have the same absolute value. Well, negative 11 is an integer, and so is 14, but they don't have the same absolute value. They have opposite signs, but they don't have absolute value. See, I think in reading this question, we assume that they're asking us about numbers that have the same absolute value, like 11 and negative 11. But it's not asking us that. It doesn't say integers of the same value. So here is your technical explanation of how this works. You ready? Opposites. That's a technical word we learned. Did you hear that motorcycle go by? Opposites. This microphone picks up everything. Opposites have the same absolute value. I'll put AV for absolute value. So not integers with opposite signs, but rather opposites, meaning negative 11 and 11, negative 23 and 23. They're opposites of the same number. If an integer is negative, its absolute value is also its additive inverse. Those are really big words that mean something very simple. If an integer is negative, let's pick, I don't know why I'm picking on 11, but let's make it negative 11. We have a negative integer now, right? We're good up to the comma. Its absolute value, what's the absolute value of 11? Is 11. Is also its additive inverse. Negative 11, 11. Additive inverses. So yeah, this is a true statement. It's a lot of big words for a very simple idea, but nonetheless, it is a fact of integers. Suppose you have the sum of two integers with the same sign. Is the sum of two integers with the same sign always positive? Well, let's see. The sum means plus, right? The sum of two integers with the same sign. So let's say negative 3 and negative 3. Okay? So this actually equals negative 3 minus 3, and so that's going to be negative 6. So that doesn't work, but 3 plus 3, these are both positives, equals 6. So no, that's not true at all. That's not true at all. Actually, the sum of two integers with the same sign has the sign of the integers. See, these are both negatives, so this is negative. These are both negatives. Remember, if there's no sign, it's assumed to be positive. These are both positives, so this is a positive. So yeah, no, this is not true. The sum of two integers with the same sign is not always positive. The sum of two integers with the same sign has the same sign as the integers. In other words, the answer takes the sign of the problem. The product of three negative integers is always negative. Well, let's see. Let's use easy numbers. It's late in the day. It's almost 4 o'clock at this point. Let's make it easy. Three integers. We got negative 2, and negative 2. Someone's knocking at the door. I shall pause this and be right back. Don't go away now. Okay, now keep in mind that product means multiply. So, negative 2 times a negative 2 will give us a positive 4. Positive 4 times negative 2 will give us a negative 8. So the product of three negative integers is negative, is true. In fact, we can take that idea a step further. The product I wrote a U, it just got sloppy. Let me start over. The product, let's start with that. The product of an odd number of negative integers will always be negative. So let's say you've got an odd number. What's another odd? 5 is an odd number, right? So negative 2 times negative 2 times negative 2 times negative 2, 1, 2, 3, 4 times negative 2. You have an odd number of negative signs, so guess what? The answer is going to be negative. On the other hand, if you have, let me pick a different color here. Let's see if that shows up. I don't know if it will. If you have an even number of negative integers, the answer will always be positive. Okay, so let's take a look at this. Let me go back to, in fact, let me go to blue. Okay, so you got a negative times a negative is a positive. A positive times a negative is a negative. A negative times a negative is a positive, and a positive times a negative is a negative. So there, with 5, an odd number, we have a negative product. The answer is negative. But let's add one more negative 2 to this thing and see what happens. A negative times a negative is a positive. A positive times a negative is a negative. A negative times a negative is a positive. A positive times a negative is a negative, and a negative times a negative is a positive. So the rule works. The product of an even number of negative integers will always result in a positive number, and the product of an odd number of negative integers will always result in a negative number answer. Product. The product of a not, yeah, will be negative, okay? Powers of negative integers are always negative. What do you think about that? Powers of negative integers are always negative. Well, let's pick a negative integer. Let's say, and again, it's late. Let's make it easy. Don't hurt me now. Let's pick 2. And our little statement here says negative integers, right? And it says the powers of negative integers are always negative. Negative 2 to the third power. How about squared? So let's see here. We got negative 2 times negative 2, and that equals a positive 4. So no, 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 no. No. What would make this statement true would be to say that odd powers of negative numbers are always negative. And that kind of goes back to our previous statement, the last, this guy, this rule. Now we have negative 2 times negative 2 times negative 2. 2 times 2, 2 times 2 is 4. 4 times 2 is 8. We have an odd number of negative signs, so the answer is going to be negative. Ta-da! Odd powers of negative integers are always negative. In part 2 of integers, we'll be going over some absolute value ideas and possibly some operation and simplify kind of things. So if you're stuck on anything, if anything didn't quite make sense, go back, rewind, watch it a little bit closer, and see if that helps.